Okay, are we in the right place?
Is this 174 classroom?
How about now? Now are we in the right place?
Yeah.
Let's see. Okay. So this is me. You can call me Mark. I'm perfectly happy with Mark, but anything respectable is fine. Okay? But I'm happy if you call me Mark. This is my email address. This is the best way to get a hold of me by far. So you can email me with any questions that you have. I look at my email all day long. And so that's good for you. It's bad for me. It's good for you. But I try to get back to you as soon as I can with any questions. Okay, so you're going to need for this course the Pre-Calc Pathways Workbook. Let's see, do I have a picture of that? Look at that. There it is. Workbook, 4th edition. There is a physical text, but you'd have to order it online. You won't be able to get a physical text. With the workbook comes online access that has an online e-text. Okay, but the important thing is that you have this physical workbook and you bring it to class every time because it has what's called investigations, which are like worksheets that I'll be assigning in class, and like you'll be working in groups. I'll be coming around and helping you. And then it has all the homework in it too. So the homework that you're doing, written homework that you're turning in. Okay, so this is the essential element, pre-calculus workbook. And you're bringing it to class every time. Okay? All right, so Blackboard is going to be our home base for the course. It's where you'll have syllabus, assignments, grades, announcements, etc. So we're going to use Blackboard as the home base. We'll go there in a second. Okay, a lot of the homework will be online using a system called WebWork, and I'm going to show you that in a second. WebWork is, the first WebWork assignment is posted and due Thursday before class. So we're going to jump right in and get our feet wet, okay? So, but I'm going to show you that in a second. But the first assignment is due, did I say 11:45? 11:30. So 11:30 a.m. WebWork will always be due before class at 11:30 a.m. Okay, we don't have a recitation or a TA. Ignore that. Let's see. Is there anything else here? Okay, so let's go. Let me show you Blackboard and WebWork. Maybe. So if you go to Blackboard, here's what you'll see. I've got a list of startup items for you for Thursday. Okay, the first is, again, the workbook. Download the syllabus, link at the left, and read it. We'll actually go over the details of the syllabus on Thursday. The WebWork, you're going to log into WebWork and begin working on the set. This is Module 2, Investigation 1. This is a typo. Thursday is the 15th, so I wrote that up here. WebWork is due Thursday the 15th. So your WebWork is due 11:30 a.m. this Thursday the 15th. Okay, so if you come over here to the course areas, syllabus first. There it is. Download it, print it. We'll go over it Thursday, okay? Assignments. They'll be assigned by date, and then I'll list what's due on that date. So here we are. The first assignment, again, is the WebWork, Module 2, Investigation 1. Okay, WebWork. So let's go to the WebWork site. So to get to WebWork, should be here. Again, so this is, I copied this from last semester, 170. So you go to webwork.asu.edu. And then you guys are going to look for 170, which is here on the first First one, first box, first name. Okay, that's what for you guys. Ashbrook. Okay, and then you won't see any of these. You'll just see this first one right here. It'll say Mod 2, Investigation 1. You won't see these below. That's what's due. So if you click on that, then you get the list of problems. Some of these problems will be pertaining to material that we cover today in class. Other problems will be things that you should be expected to know coming into the class, so more prerequisite material. So you may see algebra type problems and think, oh, we didn't really do something like this in class. Right, okay? So just know that there's in the middle, kind of middle towards the end, there's just a lot of prerequisite material that you should be able to have success on if you're in this course. So let me just show you some problems here and give you a little taste of what it is. Some problems have pull-down menus. They're like multiple choice. Okay? In this particular one, you have to get all 5 of them correct to get the problem correct, and you don't get individual feedback. On some problems, you get individual feedback on which ones you got right and which ones you got wrong. I think this first one, you don't. It just says either correct, all of them are right, or at least one of them is wrong. Okay? On this first assignment, I'm giving 5 attempts on every problem. And when you make an attempt every part of the question, because if you just do one part of the question and then use an attempt, well, you just used one attempt. It's not, you don't get 5 attempts on every part. You get five chances to hit submit, okay, to get credit. So when you are submitting answers, you're submitting all your answers. So make an attempt on everything before you submit. A very helpful thing to not waste attempts is when you're entering algebraic statements, or you're entering numeric answers, use the preview button. It'll give you a picture of what it is you've entered without using an attempt and without telling you if you're right or wrong. This can save a lot. It can also give you a clue. It can also say, hey, you put an X in here and it's not expecting an X. So that was kind of like a free, you got like a free attempt there because it gave you some info about your answer that was wrong. So use this preview answer button. It's really helpful. And don't submit until you're sure you want to go for it, okay? And down here you see it says you've attempted 0 times. You have 5 attempts remaining. Okay, next. So that's the same type. I'm going to show you something different here. These are all... Okay, so here's multiple choice. Read carefully. Some of them are expecting one answer. Some of them, more than one answer is possible. Read the instructions carefully. Okay, here's one where you're actually entering in expressions. So here would be a great chance when you put an expression in there, use that preview answer button rather than, so you can get some kind of feedback. You get a visual, you could get some tips. It could tell you put the wrong variable in without wasting an attempt. So yeah, and in terms of entering your answers, you just read really carefully, read the instructions really carefully. Oftentimes students, they will overlook something, and that's why they're not putting the answer in correctly. Okay, then there's this thing that gives you like a little equation editor. So then whatever, you can use these buttons, and then whatever you enter here, then will get transferred into the entry box. There's also little help links telling you how to enter formulas. Let's see. So I think that gives you a good idea. So there's pull-down menus, there's multiple choice, there's multiple answer, and then there's open expressions, numerical answer, all kinds of problems. So what you're going for, once you get everything correct, all the parts correct, what you'll see is, so here, I'll do this one. So D equals 50 minus x squared, and then W equals 1 million. Okay, so if I preview, first of all, if I preview, it gives me a nice image of what I've entered. Preview only, answer's not recorded. This one didn't give me any feedback. Sometimes it'll give you a little feedback if it does. And then I can submit. And then here's the feedback table. It says incorrect, incorrect. At least one of the answers above is not correct. So here it's giving me individual feedback. What will happen is when you get it correct, this should be showing up in red. The screen is not showing red, but these will show up in red. When you get them correct, you'll see green. And what you're looking for is the green bar right here. When you get the green bar underneath the feedback table, you've gotten everything right. There's nothing else to do. It just, all your answers just got saved in the system. You don't have to email me and say, Mr. Ashbrook, I just got number 7. I got them all right. Okay? So it just automatically saves it. As soon as you get the green bar, there's nothing else to do. There's no final submit or anything like that. Okay? Watch your attempts. So here it's telling me I've attempted this problem 1 time. I'm 0%. I have 4 attempts remaining. And again, answer all parts. Every time you make an attempt, answer all the parts. Okay, any questions on web work? The best way to learn it is just to jump in and do it. And like I said, I've given you 5 attempts on all the problems, which is slightly generous. It should be enough as you're figuring it out. And what's I going to say? Yeah, so there's quite a few problems, but some of them are not. There's not a lot of work to do. Some of them are longer than others. So there's 18. Get started on that tonight. Any questions? Any questions on web work? Okay. Module 2, Investigation 1, due Thursday at 11:30 a.m. All right. So we looked at web work. We looked at Blackboard. I think we covered it. Again, here on web work Blackboard announcements, you've got your 3 required tasks for Thursday. Get the workbook if you don't have it. Download the syllabus, bring it to class, and start web work. Any questions before we do some math? Yeah. Oh, it's just your ASU Write ID. Yeah, I was already logged in on my computer. So if you're not logged in, when you go through web work, it's through your ASU Write ID. Other questions? Okay. We don't have a recitation. Oh, there's one thing I want to talk about first before I go over the syllabus Thursday, and that is, in terms of exams, we're not going to take exams in class. We're going to take exams outside of class, and so I'm weighing some different options on how we're going to do that. One possible option is during test week, there would be a test at Tuesday at 3 p.m. and Thursday at 3 p.m. And so we could, if you could make one or the other, we would break you up into 2 groups such that you could either make Tuesday at 3 or Thursday at 3. Is there anybody in here who could not make either of those? Who could not do Tuesday at 3 or Thursday at 3? Too many. You guys got a class Tuesday, okay. All right, so we'll have to figure out something else. What I'm probably going to do then is it'll probably be during those weeks, it'll probably be Wednesday evenings. It'll be a Wednesday evening exam, and if you have a class Wednesday evening, then we'll make other arrangements for you. Okay? But we'll talk about that Thursday. Okay, so copy my email address, buy the workbook, download, read the syllabus, and do the first web work. Thursday, 11:30 a.m. We don't have a recitation in TA. Yeah.
Is the access code for the web work or?
Nope, you just use your ASU Write ID. Just go to webwork.asu.edu. There's no pretest. Oh, not again. All right, so let's get started. Quantities. So it would not be incorrect to say that pre-calculus is a course about quantities, the whole thing. So if you have to sum it up in one word, pre-calculus, quantities would be the word that you would use to sum up what is this course about. Now we'll be more. If we're allowed more words, then we can be more specific. But if we're just allowed one word, this would be the word we would choose to say this course is about quantities. Okay. So first we had to know, what do we mean by quantities? So real world situations. Okay. So in math classes that you've had in the past, and maybe not all of them, but maybe many of you in many of your math classes in the past it went something like this. You came to a new section in the book, and you were taught some kind of method or procedure. Normally, moving symbols, how to solve equations, how to solve certain types of problems with just the symbols and the numbers. And then if there was time at the end of the section, then they showed you some application problems that pertain to that particular method. So it was kind of like an afterthought, like here are some applications of this procedure that you just learned. Anyone identify with that? And then you go on to the next section and you do it all over again. Okay, so this class is going to be a lot different than that, in that everything we do is going to start with real-world situations. So mathematics is about modeling the real world. So when mathematics should come out of our need for it. So we're going to present a situation, and then we're going to kind of develop the mathematics that model that situation. So real-world situations involve what we're going to call objects. Objects. The workbook, okay? This classroom, okay? The class of students. So all of you, we could say, is an object. Or you could say one of you, one person is an object. So any physical thing, anything that has characteristics that can be measured, it can be considered an object. And so the characteristics of objects we're going to call attributes. Okay? Attributes. So here's my very trendy flip phone. Okay? So what are some attributes, characteristics of my flip phone? It's red. The color of it. Okay? The date. It's old, right? It's antique. Okay? What are some other attributes of it? The color, the age, what else? What's that? Okay, so she said size. Okay, we want to be a lot more specific. There's lots of ways to qualify what the size is, so it can be more specific. Volume, the volume of it. What else? The weight. What else about this? Or attributes of this flip phone? Come on, there's lots. So the weight, the volume, what else? What about other things that would tell you its size? Length, height, width, right? So the carrier that I have, the brand of the phone, these are all attributes of the phone. Lots of different specific things that describe it, characteristics of the phone. Some of those, like volume, width, length, are special. What is it about volume, width, length, height, density? Those are all special attributes that are different from color, make, model. What's different about those? Yeah, exactly. Some of those attributes can be measured. That's what we're calling a quantity. So a quantity is not a number. It's not a numerical value like 10.3 or pi or negative 100. What we mean by a quantity is the attribute, the characteristic that you can measure. The length of the phone, the width of the phone, the temperature of the phone. Those are what we're going to call quantities. Okay? So measurable attributes of objects are quantities. So a quantity is a measurable attribute of an object. Okay? So what's that? That's a dump truck. Okay? That's a dump truck. So that truck is an object. So we're going to make a list. List as many attributes of the truck as you can, and then qualify which of the ones you listed were quantities and which are not quantities. Okay? So we can make a list of 100 things here, so we want to get as many as we can. We're not going to do 100, but the point is that if you run out of ideas at 3, you shouldn't have run out of ideas. There's lots and lots of attributes to this truck and lots of measurable attributes or quantities. Okay? So go and why don't you meet someone next to you and do it in pairs, okay? Or groups of 3, whatever. So talk it out as you're doing it, okay? Come with as long a list as you can. Go. Okay, let's hear what you came up with. So, attributes. Back here in the tank top. Yeah, tell me one. All right, one at a time. So the width. Okay. We want to be a little more specific. Width of what? Width of the bed. Okay, so you're saying the width of the loader. Yeah, the width of the bed or the width of the loader. Okay, somebody else. Back here, pink shirt. Yep.
Okay. The tires.
The tires.
The height of them.
The height of the tires. Okay. How about here in front? Right here. Yeah. The number of tires. Okay. How about here, right here? Yeah.
What it's made out of.
Okay. Material. Nice. Yeah.
Like you said the width of the bed, the length as well of the whole truck.
Length of the whole truck. Good. We're doing great. How about in the blue shirt and the glasses? Yeah. The weight of the whole truck. Couple more. Up here in front. Yeah, in red shirt. The volume of the loader? Okay, is there another volume quantity we could talk about? Okay, volume of the cab. Okay, and so those are both like capacity type volumes. So those are perfectly good quantities. Those are like capacity. But what about just straight volume? You know, capacity is like how much something holds, but then there's just like how much space in the world it takes up, right? So we could also say volume of what? Yeah, just volume of the truck, which would be like not its capacity, but just how much space in three-dimensional space is all the material taking up. So those are three very different volumes. They're all volumes, but they're all different quantities, right? Okay, so let's see. So do we have more quantities or non-quantities in general here? Do we have more quantities or non-quantities? Yeah, we got a lot more quantities than non-quantities. So is there anyone have a suggestion for another non-quantity? Something that's not a quantity. Yes, ma'am. The shape. Like rectangular, you mean? The shape of the loader. How about one more, non-quantity? The color? What do you say?
Model of the truck.
Okay, model. And color. So color of, to be specific, the cab. Which is actually two colors, or three, like orange, black, and white. Okay, so let's go through and say which ones are actual quantities. Width of the bed, quantity or not? Quantity, okay? So what are we looking for? We're looking to see if it's something you would measure and put a number on it, right? Height of the tires. Number of tires. Model. No. Material. No. Length of the truck. Weight of the truck. Of the whole truck, yep. Color of the cab. No. Not measurable. Volume of the loader. Volume of the cab. Volume of the truck. Shape of the loader. No. Make sense? Okay, so this course is about looking at quantities like these, and then looking at actual two quantities at once and seeing what happens as they change together. Okay, so as quantities change together, modeling and analyzing that sort of thing. Let's see what's next here. Oh, look, there's our truck. I know it's not all that exciting, but and there it goes. All right, so we came up with quantities, and I'm just going to write a few of the ones that I remember down. So some quantities, we had the length of the truck. We had the weight of the truck. Capacity of the loader. Volume. Number of tires. And let's say, how about the volume of soil in the truck? So now we've kind of were focusing in on the attributes that are quantities. Now we can look even further and distinguish those even further, the ones that are quantities, into, now that we saw that video, into what? Ones that are changing. The quantities have a changing value, while other of those quantities have a constant value. So we saw what happened. The bed tilted up, the soil dumped out, and then the truck eventually pulled forward. Okay? So, quickly with your partner, just go through these and specify which of those quantities have a changing value and which of those quantities have a constant value, thinking about the video that we just watched. Go! Okay, how about the length of the truck? Stayed the same. It stayed the same. What about the capacity of the loader? The capacity of the loader stays the same. How much? We're talking about how much it can possibly hold. That doesn't change. Number of tires, constant. Volume of soil in the truck. Okay, so that one's changing for sure. It started out at the maximum amount, and then as the video went on, the volume of soil in that truck decreased. What about the weight of the truck? Changing or constant? Really? Anyone think constant?
The weight of the truck?
Okay, so the correct answer is unsure, because, and this is a very good point, by writing weight of the truck, it's not specific enough, right? You see, that's not a specific enough description to then determine if that quantity is changing or constant. So do we mean the total weight of the truck and its contents, or do we mean the weight of the truck? So if it's the total weight of the truck and its contents, then is that changing or constant? Changing, because it lost weight. The contents were unloaded, okay? If we just mean the weight of the physical truck, then that remained constant, even though the soil dumped out. So this is a very important lesson in terms of defining quantities, is that you have to be specific. So because there's only one changing, let's say the weight of the truck and all its contents. Now that's changing for sure. So when defining quantities, this is an important thing to note. And we saw evidence of it right here. You have to be fully specific as to what quantity you're talking about, or else there's ambiguity, or else you can't be sure sometimes about assigning a value to it or saying whether it's constant or changing. So what is it so what kind of thing is it that allows us to have changing quantities? Kind of what is the medium or the reason that some quantities change? What's going on in the background? How come we didn't have any changing quantities when we have a still photo like this? But then when I turn the video on, now we can talk about changing quantities. What is it that allows for changing variables? Okay, and that requires what? So, what's the medium for changing quantities? What's needed for a quantity to change? Time, right? Time. Oh, you should have said it. You should have said it. Someone got it. Yeah, you got time has to go by in order for us to talk about a quantity changing. If you just give you a still photo of that truck, we can imagine, imagine it going through some process or time, but you need time to have a quantity to change. Okay, so time is a quantity, and like we said before, you have to be very, very specific when you're identifying time quantities, okay, or any quantities. But relative to that video, here are 5 different time quantities that can be defined, and we could name 5 more. Okay, we could define 5 more, but here's 5 specific time quantities that can be defined in this truck situation. So I want you to determine for each one if it's constant or changing. Some of these are a little tricky, so you have to really think about it. Here's what you go back to. Constant quantity, a constant amount of time would be like finalized. It'd be like it takes this much time for this to occur. Okay? But a changing quantity takes on many magnitudes in the context. So sometimes times are defined so that it could be 1 second, it could be 3 seconds, it could be 5 seconds, it could be 10 seconds. So that's a changing time quantity. So let's see how you do on this. This is a little weird at first, but these are all valid time quantities for the truck situation. Some of them would be classified as constant time quantities, a fixed amount of time, and some of them a changing amount of time, 1 second, 2 seconds, 5 seconds, 10 seconds, 15 seconds. So work with your partner, see how these go. Changing or constant? Here's the key about changing.
Will it be
Okay, you think you've identified all 5? I'll give you a little more time. Okay, I'll give you a hint. 3 of them are constant and 2 of them are changing. Did you get it? 3 are constant and 2 are changing. Okay, let's go backwards from number 5. So let's do number 5 first. The time from the first beep to when the truck bed starts to tilt. That's the easy one, right? So that's constant. Whatever that is. 6.8 seconds, right? So that's 6.8 seconds. It was not 1 second. It was not 10 seconds. It was 6.8 seconds from the time from the first beep to when the truck bed started to tilt. Okay, the time elapsed after the truck begins to pull forward. Constant or changing? Okay, so could it be 1 second after the truck begins to pull forward? Could it be 1 second? Could it be 3 seconds after the truck started pulling forward? Could it be 7 seconds after? Yeah. So we're starting the clock when the truck begins to pull forward, and now we're talking about how much time has gone by since the truck started moving. That could be 1 second, 2 seconds, 3 seconds, 5 seconds, 10 seconds, 20 seconds. Does that make sense? That's changing. Okay, so let's hear from some. I'm going to call it the total time the truck bed spends moving. How about right here in the striped shirt? Yep, the total time the truck bed spends moving. Changing or constant? Okay. She wants constant. What do you think? You agree with that?
Yeah, because it's total time.
Total time, right? So the truck bed starts moving, we start the clock, and then it stops moving. Whatever, 9.2 seconds that the truck bed was moving. It wasn't, yeah. So that's constant. The time elapsed for all the soil to be dumped. The time elapsed for all the soil to be dumped. Changing or constant? Lots are saying changing. So after 2 seconds, has all the soil been dumped? So could this quantity have a magnitude of 2 seconds? No, it's the time. It's how much time it takes for all the soil to be dumped. So it's from when the soil, whenever we picked a starting time, to when the last, last little piece of dirt hit the ground. So this is constant. It's an amount of time for the soil to be dumped, because it's all the soil. That's the key here. All. The time elapsed since the soil first hits the ground. Changing or constant? Could it be, so could 2 seconds have elapsed since the soil first hit the ground? Could 3 seconds have elapsed? Could 4 seconds have elapsed? You see, every single time starting at 0, every positive amount of time can be, this quantity can take on 1 second, 1.5 seconds, 2 seconds, 4 seconds, 6 seconds, because it's how much time has gone by since the soil first hit the ground. So, you know, in past, when you've done application problems and you've had something situation where time was involved, so just to write down time is not acceptable anymore, because look at how many different amounts of time we could talk about. And we could, like I said, we could name 5 or 10 more from that video. We could define specifically other time quantities. So again, when you're defining quantities, you have to be very specific about what you mean. Distance is not good enough. Time is not good enough. So what distance are you talking about? What amount of time are you talking about? This is a perfect example of how just time itself in a given situation, you can have lots of defined times. Okay? All right, we'll do that, and that will be a quiz on Tuesday. So let's talk about how we represent changing quantities. What do we use to represent changing quantities? I should have seen this in the past. So now we've got this changing quantity of, say, the time since the first amount of soil hit the ground. And we want to represent that mathematically. What do we use? So delta usually just means like change, an amount of change. But so in just more in general, what do we use to represent changing amounts, changing quantities, changing values? Yeah, variables. Variables, okay? So that's what variables are about. They're about representing a changing quantity, but more specifically, look what I've underlined there. Every value that the quantity could take on. Right? If it's a changing quantity, it takes on many values. So the variable is one symbol that takes on all those values. Or it might take on one at a particular situation, but that's what a variable is about. It's about a symbol, a letter that represents, takes on every value that that quantity could have. Okay, so we want it to define a variable well. We've got 3 criteria. So the first thing is, when you define a variable, you have to the description must be of a quantity, not the object itself. Okay, so for instance, M equals marbles. How did I do? Did I meet this criteria? What is marbles? Remember from the beginning of class. What would we classify marbles as? That's an object, right? That's an object. That's not a quantity. So when we define a variable, so this is no good. When we define a variable, M equals, this thing has to be a quantity. It has to be some measurable attribute. Okay? So what are some possible measurable attributes of marbles that we might want? Number of marbles. What else? Okay, so size is not, so size is, what do you mean by size? Circumference of the marbles. Weight of the marbles. Volume of the marbles. Density of the marbles. Okay? Temperature of the marbles. Probably, when you see M equals marbles, probably it means number of marbles. But you can't be sure. That's the whole point. It could be the weight or the volume. Okay, and so this word, we've been hammering this all class. When you make a description, it's got to be fully specific. It's got to be fully specific. So we say M equals. Let's go with volume. Or weight. Let's go with weight. Weight of all the marbles. Have I been specific enough in terms of what my quantity is? Sure. Weight of all the marbles. That's a nice specific description. But actually, it's still not enough. Now there's still something missing. We got one more criteria to define this variable well. Anybody know what that is?
Area the marbles are taking up.
Oh, well, so that's a different quantity. So like for instance, this quantity that I've defined, it's still there's something missing if we're going to define this variable m. Yeah. Yeah. So what are we going to measure it in? Okay, appropriate units. So in ounces. Now I've got a well-defined variable. What are the criteria? It's a quantity, first of all. It's not. We're not calling the variable the object. It's a characteristic of the object, first of all. It's fully specific about what we're talking about, and it's got the appropriate units. Okay, so notice when we talked about quantities, we never specified units. But then with variables, we say, oh, you need units for variables. Okay? Why might that be? Why is that? Any ideas? So when we just talk about quantities themselves, we never specified that we needed units. We never talked about units. But now, to define a variable, we need units. And there's a good reason for that. Any ideas? It goes back to what the variable is. What is the variable again? And how is the variable different just from just the quantity? So what is the variable about? Yeah.
Changes.
What's that?
It changes.
Okay, it could change. That's true. But the quantity is changing. But what's different about the variable now? What is the variable? So is the quantity. And so is the quantity. What did we say a variable was? Okay, so here's the key. The variable then is every value that the quantity can take on. So now, if m equals 8, if I didn't have units here, what would the 8 mean? We don't know. Pounds, ounces, grams, what is it, right? So what is it? So because the variable now is saying that variable represents the number, the current value of the quantity. It represents the current value of the quantity. We're assigning a number to it. And in order to know what that number is about, you have to know what units you're measuring in. But as a quantity, the weight of the marbles as a quantity is sufficient because it's just how much does it weigh? How much weight is there? And that doesn't require a unit until you're actually putting a number on it. And that's what the variable is going to take on those numbers, those values of that quantity. So you got to have that unit when you define a variable. Not necessarily when you're talking about the quantity. Like, say, the distance from me to the wall. That's a valid quantity. It's that far. It's from here to there. It's that far. Now if I say d equals the distance from here to there, well now d is going to take on numbers. So now you got to say, is that d variable, is it going to be meters or feet or inches or something else? But just the quantity itself, distance, it's just how far it is. From here to there, it's just a measurable attribute. It's just that how far. Okay, we already did that, so let's look at this. Okay, so let's practice. At the bookstore, familiar place right now, right? At the bookstore, each manager supervises 8 cashiers. The number of employees needed fluctuates throughout the semester. Okay, so I'm going to say M equals managers, C equals cashiers. How'd I do? You're shaking your head. Tell me. Explain. Oh wait, so someone else's mouth is moving. Who? Yeah, well, who was talking? That's fine. Who's? Yeah, okay. She let you off the hook. Okay.
Thank you.
Yeah.
I would say like the number of managers, not managers.
She wants to say M is number of managers rather than managers because managers is an object. It's not a measurable attribute. So right, this is not good because we're violating rule number 1. We're calling our variables objects rather than what attribute we're measuring about them. So instead you want to say number of managers, number of cashiers. Okay? And so this is the units, when you do this, number of managers, number of cashiers, the units are built in. You're just counting, right? You're just saying how many. So you would, the unit is implied. It's just how many, right? Okay, so what I want you to do is write a formula that expresses the number of managers in terms of the number of cashiers. Write a formula that expresses the number of managers in terms of the number of cashiers. And I'll just give you a heads up. In my past experience, this is not an easy exercise. Many, many students get it wrong. I'll just say that much. Go, work on it. So this is not a simple, easy exercise. You got to think it through.
It doesn't say there's going to be it says it fluctuates through the semester. So you can have 5 and still 1 man. 1 man and 1 company. It's possible.
One of those or something else? Okay.
So
Okay, so I heard some different answers. So the first thing we got to know is, what does this phrase mean, in terms of? So is my formula going to be M equals something with C's in it? Or is it going to be C equals something with M's in it? If I want a formula that expresses the number, I want to express the number of managers in terms of the number of cashiers. First or second? Oh, everyone. So I want to know what the number of managers is in terms of, or as an expression of, the number of cashiers. First. Right? Because I'm writing M, I want to know what the value of M is in terms of, or what does it equal as an expression of C. This is something we see all semester, okay? You got to have that down. So we want to write how many managers there are as a function of, or as a formula of, or in terms of cashiers. So we want to take the number of cashiers and do something to it to get the number of managers. That's what this is saying. We want to take the number of cashiers and crunch on it in order to get the number of managers. So that would be this one. Do you see that? We're going to take the number of cashiers, manipulate it, do operations, and then it'll tell us how many managers there should be. Okay? So it'll be that first one. So if each manager supervises 8 cashiers, then each manager supervises 8 cashiers, right? Let me give you a tip for writing formulas or trying to come up with a formula or an expression. Make a table of values. The table won't lie. So we'll do M and C. Okay? So when we have one manager, how many cashiers should we have?
8.
When we have two managers, how many cashiers? Is there any doubt that we're making this table correctly? There was a lot of doubt about this, but this, we should be solid on this. For every manager, there are 8 cashiers, right? So 10 managers means 80 cashiers. Last week, right? Or this week, okay? So how do we do? M equals 8C. Now we can test it. Is it right? 8 times whatever C is gives you what M is. Oh no, right? Oh no, that doesn't work. What do we do to the C value to get the M value? That's what we're asking. We want M in terms of C, so we want to divide by 8, right? So if you got that, some of you got that, good job. But again, let me just try to remember this. If you need to write a formula, if you need to write an expression with variables in it, make a table, get some values down that you're sure about, and that will lead you to the right result. Again, so M in terms of C would mean that we've got the value of C, and we're going to have a formula on C. It's going to act on C and give us M. That's what this means, number of managers in terms of number of cashiers. Okay, so that hopefully that's going to be really easy. Okay, so writing that formula expresses the number of cashiers in terms of the number of managers. Check it with numbers. Actually, check your formula with numbers. Make sure it's right. Okay, so New York City. Is this going to be M equals something with C's, or is it going to be C equals something with M's? C equals something with M's, right? C equals something with M's. And what do we do to the number of managers to get the number of cashiers? Yeah, so what I'm going to do to my number of managers, M, to get the corresponding number of cashiers? Multiply by 8. So if there's 3 managers, how many cashiers? There's 3 managers. 24. Does it pass? Does it meet this situation? Yeah. 3 managers, 24 cashiers, because there's 8 cashiers for every manager.